Assalamu alaikum wa rahmatullahi wa barakatuh. Here Mrs. Hada Dalibalta again. Welcome dear grade 8 students. In this video we are going to make a quick revision about the relative positions between circles in order to start training exercises. So let's go ahead. As we said in the previous videos, we have the externally disjoint circles. Here is the figure for externally disjoint circles. And we have that the distance between the centers OO prime is greater than the sum of the radii. OO prime here, as you see, is greater than R plus R prime. Now we have also the internally disjoint circles. The internally disjoint circles, as you see here, this is circle C and this is C prime. This is the center O and that's the center O prime. So as you see, the distance between the centers OO prime is less than R minus R prime. Surely we put the larger radius than the smaller radius. So we make subtraction. We subtract R minus R prime and we put the larger radius minus the smaller radius. Now we have also the externally tangent circles. Here are the externally tangent circles. We can put the circle here or here. No problem. So we can make it externally from that side. And as you see, OO prime, the distance between the centers, is exactly equal to R plus R prime. So I can draw a circle here. Let's see. Let's make it, okay, no. Okay. That's, for example, an externally, these are externally tangent circles. And if we join, for example, the radius from here to here, and the sum of the radii is exactly equal to the distance between the centers. Also, we have the, let's remember, the internally tangent circles. Now, about the internally tangent circles, here is a figure. As you see here, we have that the distance between the centers OO prime is exactly equal to the difference of the radii. Of course, as I told you, we put the larger radius minus the smaller radius. Now we have the intersecting circles, as you see, and the relation between the centers, or the distance between the centers, is bounded between the difference of the radii and the sum of the radii. So I'm making just a quick revision for all what we said previously in the previous videos, and that's why I'm moving quickly and making a tiny revision for what we did. And here we have the concentric circles, who are circles having the same center but different radii. As you see, the green one and the purple one are different radii circles, but they have the same center. Okay, we call them concentric circles. We have also the equal circles. They are equal circles, but they are apart. They are disjoint, externally disjoint, but they are equal. They don't have same centers, but they have equal radii. So as you see here, C and C prime are equal circles. Now, if equal circles and concentric circles combine together, we are going to get the confounded circles. Okay, so the confounded circles are circles that are having the same radii, the same radius, and they have the same center as well. So as you see, it's a circle above another circle. And finally, we are going to talk about the equal intersecting circles. In the equal intersecting circles, as you see here, they are circles that are intersecting, but also they have the same radius. They have equal radius. Okay, so that's why when I'm going to talk about an axis of symmetry, I can consider the line of intersection points of the points of intersection as an axis of symmetry also. And the intersecting circles, if we have intersecting circles, for example that one and that one, when they are not equal, okay, we consider the line of centers as an axis of symmetry, but we cannot consider the line joining the points of intersection as an axis of symmetry. That part here is not equal to that part here. Any part to the right is not equal to any part to the left. But any part up is equal to any part down. While in equal intersecting circles, when they are equal, we can notice that any part to the right is equal to any part to the left, whether size or angles or whatever, and any part up is equal to any part down. So that's the difference between equal intersecting circles and intersecting circles as well. In equal intersecting circles, I repeat, we have two axes of symmetry. One of them is the line holding the centers, and the other is the line holding the points of intersection. While in just intersecting circles that are not equal, as this figure here, the only axis of symmetry is that one, the line holding the centers, O and O prime. That's our revision. And let's remember also that always the distance between the centers is bounded between r minus r prime, the difference of this radii, and r plus r prime. And here, as I told you, mentioned that AB and O prime are axes of symmetry.